In this chapter, we're going to be talking about various different segments, or we're going to start the chapter off, I should say, by talking about the various different special segments that exist within a triangle. We're starting off with a mid-segment of a triangle. And the way that I want to start it off is by drawing for you the mid-segment of a triangle, and then you kind of realizing what would be the definition of it. So let us consider this triangle ABC with this point M here and this point N there. And you'll notice what? Lots of painful things. Segment MN is a mid-segment of the triangle. So you'll notice that the definition that I'm giving to you starts with the phrase, a mid-segment of a triangle is a segment connecting, well, what do you think it's connecting? To what? Look at the, look, oh, wait, whoa. Let me backtrack. Do we see that segment MN is connecting the points M and N?
Wow.
Okay, I know, don't hurt yourself. All right, now here's my question. What are M and N? What vocabulary term could I use to describe the points M and N, Mariah? No. Yes. M and N are midpoints of the sides of the triangle. So a mid-segment of a triangle is a segment connecting midpoints of two sides of the triangle. And what I want to emphasize to you is that I could have also identified this point down here, let's say it could be L, such that this is congruent to this. And then, do you see that the diagram would have three mid-segments? Okay, however, in the interest of really noticing the relationships that exist between a mid-segment and other sides of the triangle, let me ask you, do you notice anything? Do you have a hunch about something? MN sure looks like it's what? Is there a relationship that you have a hunch exists in this diagram? Addie?
Parallel to BC.
Absolutely. That's one of our properties of a mid-segment. The mid-segment is parallel to the third side. Anything else?
It's perpendicular to AC.
It's not perpendicular to any of this, not necessarily, no. Now let's bring back, give me a second, put your pencils down a second. I want you to observe more so than focus on scribbling. Consider these segments that I had previously. Look at, Taylor, you have an observation?
Is a parallel to AC?
Well, yes, all of the mid-segments will be parallel to their third side, absolutely. But what I'm wanting to ask you is look at those four smaller triangles in the original triangle ABC. What do you think is true about all of those smaller triangles? They are all going to be congruent. So if I asked you, what is the ratio between triangle AMN and triangle ABC, do you have a hunch on that? Like the length of AM. It's not 1/4. Look at it carefully. AM to AB.
half?
2 to 4.
It's half. Yes, so that means that the mid-segment,
Is 2 to 4.
the mid-segment is half. The third side. Okay, I apologize if that whole, there's 4 congruent triangles inside this one triangle kind of threw you for a loop for a moment. But the point that I wanted to emphasize, ladies and gentlemen, is that this triangle down here, triangle MBL, and triangle LNC are congruent. That's the point that I wanted you to notice. And that 2 of these, there's 2 of these segments, whereas MN, there's only 1. So there's the mid-segment is half the third side. So similarly, ML is half of AC. It'll probably, I kind of said it all kind of weird, and I apologize. When we deal with the numbers, it'll be much more simple. No, don't panic. The term, and this came up in my first period, and it went a lot more smoothly, because an observation was made that the triangles are similar. And that's a vocabulary term that we haven't dealt with yet. But similar just means that they're the same shape, but not necessarily the same size. And notice that triangle AMN is oriented the same as triangle ABC. Well, AM, there's only 1 of these congruent segments, whereas AB, there's 2 of them, which brings up that ratio that Taylor observed, that each of these triangles is half as big as the original triangle. Let's take a look at starting simple, just identifying sides that are parallel based on that first property of a midsegment. So in problem 1, I'd hope that you'd realize, based on the markings, that I have all 3 midsegments drawn in this diagram. So what's parallel to what? Which midsegment is parallel to what side of a triangle? Oh,
MN is parallel to DE.
MN is parallel to DE. Isa,
GF is parallel to
say that again?
GF is parallel to ON.
Yes. Someone else, please. So far, I've identified 2 of my midsegments and the third side that they're parallel to. Stephanie.
Segment OM is parallel to segment EF.
Segment OM is parallel to EF. Okay, so take a moment, please, and work through the your turn for problem 1 within your group. Please realize, however, that part A doesn't have a diagram to go with it. You might want to draw the diagram to make it easier to figure out what's parallel to what. Based on some of the conversations and stuff I'm seeing on your papers, it sounds like you're either stumped or totally ready to compare your answers to mine. If there's something on the screen that's unclear, I want to make sure to address it.
Oh yeah. Test and
Make it up as soon as possible. Thursday, yes.
so when should I
They say it.
During lunch or after school, but not after school, the academic meeting. Question?
I was gonna ask something that everyone said wrong. I was gonna say compare those 2 triangles that were overlapping, and then I realized you couldn't. I still got 65. I just didn't keep the process.
Okay, but that makes sense. All right, let me clarify something. Shh. Based on some of what I'm hearing, we're still kind of fuzzy about why angle VUO is 65 degrees. Because VU is a mid-segment, remember, one of the properties that I gave you on that first screen was that it would be parallel to the third side. Well, that means VU is parallel to MN. If it helps, turn the diagram a little bit And you're looking at these two parallel lines, and what I would want you to observe is that the angle that you were asked for is right here. It is a corresponding angle to the 65 degrees that we were given. I know corresponding angles were a whole 2 chapters ago, but this stuff doesn't go away. You need to make sure that you're remembering these angle properties. They're not going anywhere. Okay? Any further confusion on this screen? Yes?
Let's see.
Okay. All right, in problem 2, I am given that there are midpoints, gentlemen, in this diagram. I go from there to realize that segments GH, HK, and GK are all mid-segments. They're giving me various lengths. They're asking me for various lengths. Myself personally, I would take every piece of information that they're giving me and label it in the diagram. So I know that GH is 20, RS is 28, and RH is 22. So one of the things that I noticed a student doing in an earlier class that I thought was fantastically brilliant, that I'm going to share with you, is after she labeled the diagram with what was given to her, she took it the next step further and remembered that because these points, G, H, and K, are all midpoints, I've got some congruent segments going on. So let me go step by step. Is there any segment congruent to RS? Yes or no? Not necessarily, no.
No.
Okay, so no, I don't have any other 28s to write down. My next question, how about this RH of 22? Is there anything else in this diagram that's going to be 22? Catherine? I know HT is going to be 22. Anyone else see something that's going to be 22? Hope?
GK.
GK will be 22. Fantastic observation. And then, what else was I given? I was given that GH is 20. Is there anything else in this diagram that you see will be 20? Michael?
SK is 20.
SK is 20. And then, Haley? KT is also 20. Oh, look at all of that stuff I now know. Now let's figure out what they wanted from me. They wanted the length of KH, the length of ST, and the length of GK. Length of KH. Oh, that's not one of the lengths that I labeled. I actually have to think now. Daria, did you think?
It's 14.
It's 14. Remember, because KH is a mid-segment, it's going to be half the third side. How about ST? What's the length of ST, Hope? 40. And the length of GK, oh look, we labeled it. It's 22. Okay, so once again, there's a reason why I always urge you in your homework assignments to copy the diagrams down so that you can write those measurements in the diagrams, because of course you're not writing in my books. Take a moment please within your groups and work through the your turn problem too. All right, based on what I'm seeing, and ladies, gentlemen, please check your answers.
I'm feeling pretty confident.
I'm loving that you're feeling really confident about it. Before we activate today's daily quiz on Socrative, let's take a look at those examples that you have in your notes labeled before Socrative. Take a moment within your group. Let's go ahead and go over these examples, please, before we activate Socrative. Ladies.
This is 20.
In number one person, please. What segment is parallel to segment JK Benjamin?
ON.
Segment ON, yes. Same thing. I do speak Yawnies. Number two, if the length of LK is 46, one person, please. What is the length of NM, Michael?
23.
It is 23.
3.
Finally, for number three, ladies, I'm almost done. Taylor, don't just give me an answer, give me an equation, please.
5x plus 20 equals 40.
5x plus 20 equals, yes, it is 40. I want to make sure that we understand why it's 40. The mid-segment is the 20. So we double the mid-segment and it will equal the third side. So that's the equation that you want to set up.
We have this done 5x plus 20 equals 40.
Absolutely, yes, that's what he said. I just wanted to make sure that people understood why it's 40. Okay, so 5x plus 20 equals 40. 5x equals 20, so x is 4. Am I done with the problem?
Yes.
Yes, they did in fact only ask me for the value of x, but I did want to remind you, be ready for them to ask you for the length of the side. It could happen. Be ready for it. Remember, that would mean you have to do Caitlin's favorite phrase, plug and tug. Yes.
Are there proofs in this chapter?
There will be indirect proofs, but they'll be very, very small.
Should I just,
No, no, no.
should I just go?
No, none of that.